OpenAI's meteoric rise in generative AI has been built on Nvidia's silicon. The company's flagship models, from GPT-3 to ChatGPT-5, were trained and run on thousands of Nvidia GPUs. By 2025, OpenAI's services had amassed over 800 million weekly users, and meeting that demand meant buying virtually every high-end Nvidia chip it could get. In the world of AI hardware, Nvidia has long been the uncontested king. But what happens when one AI lab grows so big that bending the knee to this king starts to hurt? Nvidia dominates modern AI computing. By some estimates, it holds over 90% of the market for discrete GPUs, graphics processors, including those used for AI in data centers. Its success isn't just about powerful chips, it's about software. Nvidia's CUDA platform has become the default language of AI. Universities teach CUDA. Researchers build on it. Nearly every major AI framework is optimized for it. This CUDA dominance has created a moat that for years kept challengers at bay. If you wanted top performance for training cutting-edge models, you needed Nvidia GPUs. OpenAI learned this early, collaborating with Nvidia from its inception. In fact, Nvidia CEO Jensen Huang personally delivered OpenAI's very first DGX supercomputer back in 2016. A symbolic handoff of the keys to the AI kingdom. This one-sided reliance has economic and political implications. A single Nvidia H100 GPU, the workhorse of AI training in 2023 to 2025, costs upwards of $40,000 on the market. And that's if you can get one. Demand far outstrips supply, with Nvidia essentially selling every AI chip it can make. Hyperscalers and AI labs were projected to spend over $300 billion on AI hardware in 2025 alone. For OpenAI, which uses tens of thousands of GPUs, the hardware bill soars into the billions. The power dynamic is stark. Nvidia's 2025 revenue is expected to exceed $200 billion, roughly 6 times AMD's sales. Nvidia's profit margins are enviable too. By controlling the entire stack, chips, software, networking, Nvidia captures the lion's share of value from the AI boom. OpenAI, like every AI company, has effectively been paying tribute to the king in the form of high margins and upfront capital for GPUs. This dynamic has even caught policymakers' attention. In early 2025, the White House spotlighted the need for massive AI infrastructure investments, up to $500 billion, in part to ensure no single chokehold stifles AI progress. Relying on one vendor, however advanced, concentrates enormous power in one place. Technically, Nvidia's leadership also shaped what AI models could do. The CUDA software ecosystem meant that the latest optimizations, libraries, and tools all favored Nvidia GPUs first. Engineers fluent in CUDA number in the tens of thousands worldwide, whereas those experienced in alternatives are only a few thousand. It's a self-reinforcing cycle. More developers use CUDA, so more libraries support it, which attracts even more developers. For OpenAI, this meant hiring talent and designing systems around Nvidia's platform, effectively standardizing on the king's terms. The result? Incredible AI breakthroughs, but at the cost of deepening dependency. Was OpenAI comfortable being tethered to one supplier? The strain began to show as OpenAI scaled. Running ChatGPT and training new models demanded ever more compute. Sam Altman, OpenAI's CEO, openly mused about needing 250 gigawatts of AI compute by 2033, an almost unthinkable scale. The entire world's data centers, by comparison, are only a fraction of that. It was clear that no single chip maker, not even Nvidia, could easily satisfy that hunger alone. Moreover, relying solely on Nvidia left OpenAI exposed to supply shocks and price hikes. What if Nvidia couldn't deliver enough chips on time? What if geopolitical issues or export restrictions constrained Nvidia's supply chain? These questions loomed as existential risks. OpenAI's partnership with Microsoft had partially shielded it. Microsoft's Azure bought Nvidia GPUs by the truckload on OpenAI's behalf. But even Microsoft faced the same supply bottlenecks. By mid-2025, GPU shortages were a common headache for anyone building large AI clusters. Some cloud providers and startups reported wait times and inflated prices. Officially, an H100 lists around $30,000, but unofficially some buyers were quoted double that in the grey market. The one-sided reliance was as much Nvidia's problem as OpenAI's. Nvidia couldn't magically expand fab capacity overnight, and every extra chip for OpenAI was one less for another customer. Tensions were political too. US regulators, keen to maintain leadership, encouraged diversity in the AI supply chain, fearing that a single point of failure or control could hinder progress or raise national security concerns. So in 2023 to 2025, OpenAI found itself in a paradox. Nvidia was both its greatest enabler and a potential shackle. The AI crown that Nvidia wore had to be respected, bending the knee by continuing to buy tens of thousands of its GPUs, yet OpenAI also started plotting a way to loosen that golden shackle. The company explored designing its own AI chips with Broadcom, a project still in early stages, aiming for late 2026. It quietly began writing more software in a hardware-agnostic way, testing AMD cards for compatibility on smaller workloads. Still, no serious alternative existed at scale, until late 2025. That's when OpenAI made a dramatic move, one that would effectively ignite an AI civil war in the GPU world. Enter Nvidia's Rubin platform. In September 2025, OpenAI and Nvidia announced a massive deal. At least 10 gigawatts of new Nvidia GPU systems for OpenAI, with Nvidia even committing $100 billion to help fund OpenAI's build-out. The first phase, slated for 2026, would use Nvidia's next-generation Vera Rubin architecture. Named after the pioneering astronomer Vera Rubin, this platform promised unprecedented training and inference capability, essentially AI supercomputers on a new scale. On the surface, this looked like OpenAI doubling down on its loyalty to the king. 10 gigawatts is an enormous capacity, millions of GPUs, cementing Nvidia as the core of OpenAI's future. Jensen Huang proclaimed it the biggest AI infrastructure project in history. Sam Altman lauded that no partner but Nvidia could do this so fast. It was a public bow to the king's power. But behind the scenes, something had shifted. The terms of that partnership signaled a more balanced relationship. Rather than just buying chips, OpenAI secured a pledge that Nvidia would invest in OpenAI, effectively returning some capital and intertwining their fates. OpenAI would work closely with Nvidia to co-optimize hardware and software roadmaps, influencing Nvidia's future designs for its needs. In other words, OpenAI was no longer just a customer, it was becoming a partner with influence. The stage was set for a new game. OpenAI was positioning itself not merely as a buyer of chips, but as a power broker that could play one supplier against another. The question was, would there ever be a credible other supplier to balance Nvidia? Enter AMD. On October 6, 2025, the tech industry was jolted by news that felt almost cinematic. OpenAI announced a multi-billion-dollar alliance with Nvidia's chief rival, AMD. If Nvidia was the empire, AMD now emerged as the rebel alliance, backed by OpenAI's newfound resolve to foster competition. The deal's headline numbers were eye-popping. OpenAI committed to purchasing 6 gigawatts of AMD's Instinct GPUs over the next several years. To put that in perspective, 6 gigawatts of AI compute is an astounding amount, roughly equivalent to the electricity consumption of 5 million US homes or about 3 Hoover dams of power. In practical terms, it means hundreds of thousands of high-end GPUs. For AMD, a company that had only a small slice of the AI market until then, this was a transformative order. The partnership centers on AMD's Instinct MI series accelerators, specifically the upcoming MI450 GPU, part of the MI400 generation. The first 1 gigawatt deployment of MI450-based systems is scheduled for the second half of 2026. This timeline aligns closely with Nvidia's Vera Rubin rollout, suggesting OpenAI will bring up AMD-powered capacity in parallel with Nvidia's next-gen capacity. Over the multi-year deal, OpenAI and AMD will collaborate across at least 2 GPU generations, starting with the MI450 in 2026 and extending to MI500 and beyond. In fact, AMD noted that this collaboration began with the MI300X and continued with the MI350X series, implying OpenAI had already been giving feedback on AMD's designs even before the public deal. At AMD's June 2025 event, CEO Lisa Su acknowledged OpenAI as a key partner, providing input for MI300 and MI400 series chips. The Rebel Alliance wasn't spontaneous. It had been quietly brewing. What truly grabbed headlines was the creative structure of the deal. AMD isn't just selling chips, it's effectively betting on OpenAI's success. Under the agreement, AMD granted OpenAI a warrant to purchase up to 160 million AMD shares at $1 each. That represents roughly a 10% stake in AMD if fully vested, worth over $15 billion at AMD's pre-announcement stock price. But OpenAI can only earn these shares by following through on the purchases and hitting certain milestones. The first tranche vests when that initial 1 gigawatt of MI450 systems is delivered. Further tranches require OpenAI to scale to the full 6 gigawatts, and even hinge on AMD's stock price reaching targets up to $600 per share. In essence, AMD is saying, help us drive our stock to the moon by buying a ton of our chips, and we'll cut you in on the upside. This unprecedented alliance aligns incentives on both sides. OpenAI now has a direct interest in AMD's success. It could become a major AMD shareholder, and AMD in turn is tied to ensuring OpenAI's AI supercomputers thrive. One analyst called it transformative, not just for AMD, but for the dynamics of the industry. OpenAI's AMD alliance jolted investors. AMD's stock surged over 30% on the announcement, its biggest jump in nearly a decade. This one-day leap added around $80 billion to AMD's market value, reflecting a sudden belief that AMD could seriously challenge Nvidia in AI. The chart above shows how AMD's share price spiked upon news of the deal, rightmost point, a stark contrast to its gradual climb earlier. Investors saw OpenAI's commitment as a major validation of AMD's AI chips, effectively crowning AMD as a viable second source. Why is OpenAI doing this? The strategic calculus comes down to diversification, leverage, and technology. OpenAI's president Greg Brockman explained that they have a diversity of workloads, and it will require a diversity of chips to meet their needs. Training cutting-edge models, the very large, complex neural networks, is one type of workload. It demands the absolute bleeding edge in performance and a highly tuned software stack. Inference, running those trained models millions of times per day to serve users, is a slightly different beast. Inference at scale still needs powerful hardware, but it places at least as much emphasis on throughput, efficiency, and cost per query. Critically, inference can be more flexible in the hardware it runs on. Once a model is trained, it can often be exported to run on various platforms with minimal accuracy loss, as long as the platform supports the necessary operations. Nvidia's advantage is clearest in training, where their end-to-end software stack, CUDA, QDNN, TensorRT, etc., squeezes maximum performance out of GPUs. As one Microsoft Azure engineer observed, in training, that is where CUDA really shines, and most experts aren't yet comfortable switching due to the entrenched CUDA expertise. But for inference, the same engineer noted, you're not necessarily married to CUDA. The primary challenge in inference is having enough compute capacity and scaling it efficiently, rather than ultra-fine software optimizations of training algorithms. In plainer terms, if you have 1,000 adequate GPUs, you can serve a model to millions of users, even if each GPU is not the absolute top performer. This is where AMD comes in. AMD's instinct. GPUs have competitive raw hardware specs, in some cases even superior on paper to Nvidia's equivalents, but historically lagged in software support. By directing AMD hardware toward inference work, OpenAI can avoid or minimize the trickiest part of that lag. Consider AMD's flagship 2023 chip, the Instinct MI300X. It boasts 192 gigabytes of high-bandwidth memory on a single GPU, compared to 80 gigabytes on Nvidia's A100/H100. This huge memory pool allows an MI300X to hold very large AI models entirely in memory, which is great for inference on large language models with long context, like those powering GPT-4 with big prompts. In fact, AMD claimed MI300X can outperform Nvidia's H100 in certain AI throughput metrics. Those claims come with caveats. They're peak theoretical numbers with specific sparsity optimizations, but they underscore that AMD's hardware is not a weak link. It's the software ecosystem that's been the hurdle. That software hurdle is gradually lowering. AMD's ROCm, Radeon Open Compute Platform, is the company's open-source answer to CUDA. For years, ROCm trailed CUDA in both features and adoption. However, AMD has poured resources into improving it. By late 2025, industry experts noted that ROCm's stability and performance had made significant strides. AMD announced that the latest ROCm 5/6/7 updates yielded up to 3.5 times inference throughput improvements over previous versions. Moreover, AMD's tooling allows developers to port CUDA code to ROCm via HIP, heterogeneous interface for portability, which has become very close to CUDA in terms of portability and syntax, according to engineers. The ecosystem gap remains. A LinkedIn analysis found perhaps 1,000 to 2,000 engineers with hands-on ROCm experience versus 10,000 to 50,000 with CUDA. But OpenAI's backing itself helps here. If OpenAI ensures that popular AI frameworks, PyTorch, TensorFlow, JAX, etc., run smoothly on AMD for their own use, those improvements flow back to the community. This deal effectively makes OpenAI a co-developer of AMD's software stack, accelerating its maturity. OpenAI has every incentive to optimize frameworks for AMD now. From AMD's perspective, winning OpenAI's business is a watershed moment. A breakthrough achievement for AMD, as one analyst put it. It validates years of AMD's investment in data center GPUs. AMD's executives have been candid that breaking into AI required patience. They often cited CUDA's inertia as the biggest barrier. Now, they have the best possible reference customer. If the leading AI company trusts AMD for its core infrastructure, other companies will surely take notice. Patrick Moorhead, a noted chip industry analyst, commented that this will attract even more Tier 1 customers to AMD. In other words, OpenAI's deal could be the catalyst for a broader ecosystem shift, giving AMD a foothold in deals with cloud providers, enterprises, and government AI projects that until now defaulted to Nvidia. It's worth noting the economic logic for OpenAI as well. By introducing competition, OpenAI can potentially lower its own costs. Nvidia, as the market leader, has had the luxury of pricing power. With AMD in the mix, pricing for AI GPU contracts may become more competitive, or at least, OpenAI gains negotiating leverage. OpenAI's API business and consumer services, like ChatGPT, are very compute-intensive. Inference costs can accumulate to be larger than even training costs over time. OpenAI's 2023 operating costs were widely reported as extremely high, with daily infrastructure costs estimated around $700,000, and by 2024, estimated total operating expenses at about $8.5 billion, much of it cloud compute. If AMD hardware can deliver slightly higher memory or better throughput per dollar, it could reduce the cost per query of services. Even a small percentage cost reduction at OpenAI's scale translates to huge savings annually. However, OpenAI's move to use AMD is not about abandoning Nvidia, it's about strategic workload placement. Sam Altman himself emphasized, right after announcing the AMD deal, that OpenAI will also ramp up its investments in Nvidia chips. This isn't a zero-sum switch, it's a diversification. We might see a division of labor. Future GPT-6 or GPT-7 models get trained on Nvidia's latest and greatest, where the software is most battle-tested. Then, when deployed to millions of users, a significant chunk of the inference could run on fleets of AMD GPUs tuned for that purpose. And perhaps some model training, especially for less mainstream models or subsidiary systems, will happen on AMD as their tools improve. By late 2025, OpenAI essentially has 3 irons in the fire for compute. Nvidia for primary training needs, with 10 gigawatts pledged. AMD for a large portion of scaling out inference, 6 gigawatts pledged. And a longer-term bet on custom AI chips with Broadcom for specialized efficiency. This trifecta ensures OpenAI is no longer completely beholden to any single chip supplier. The Rebel Alliance isn't about destroying the king, it's about ensuring the empire no longer has a monopoly on power. Still, The emergence of this alliance fundamentally changes the power dynamics in the AI industry. The next act examines the fallout, how this gamble reshapes roles for AMD, Nvidia, and OpenAI itself. The dust has now settled on the twin announcements of late 2025. OpenAI has effectively anointed two emperors in AI hardware, Nvidia and AMD. What does this new world order look like? And how does it redefine the relationships and fortunes of each player and the wider ecosystem? First, OpenAI's own role has evolved dramatically, from customer to kingmaker. Just a year or two ago, OpenAI was essentially a hungry consumer of whatever chips it could get, mostly from Nvidia, via Microsoft's Azure. It had little bargaining power beyond what Microsoft wielded on its behalf. Fast forward to now. OpenAI has orchestrated deals with both GPU giants, extracting major concessions from each. With Nvidia, OpenAI secured up to $100 billion in direct investment capital to fuel its expansion. With AMD, OpenAI negotiated an equity stake that gives it potential influence over AMD's future direction. In one deal, OpenAI is the investee, Nvidia betting on OpenAI's growth. In the other, OpenAI becomes the investor, taking a piece of AMD. This is a remarkable position. OpenAI is no longer just an AI lab or service provider, but a strategic power center in the semiconductor industry. By forcing a two-horse race, OpenAI has made itself the arbiter of competition. It can allocate its massive workloads in whatever proportion it sees fit, effectively rewarding the vendor that executes better or offers better terms. It's not far-fetched to say that OpenAI's purchasing decisions could determine each company's market share in the AI chip space over the next few years. The leverage that comes with this is immense. For instance, if Nvidia's next chips underperform or are delayed, OpenAI could shift more deployments to AMD, and vice versa. In that sense, OpenAI now has a seat at both suppliers' strategy tables. Both Nvidia and AMD have agreed to deep roadmap coordination with OpenAI, a level of collaboration usually only seen between foundries and their largest customers like Apple. OpenAI will likely influence design choices, e.g. more memory, interconnect features, support for certain data formats, in future GPUs to better suit its AI models. This influence extends beyond any one company. It will set new norms in AI hardware requirements that could benefit the whole ecosystem.